The last thing we're going to take a look at are holes in our graphs. So what happens when there's a hole is when you have a common factor completely divide out of a rational function, it creates a hole. So we've talked about these asymptotes, these voids where no part of the graph exists, and it causes the split in the graph, which gives you the two curves that kind of go opposite of one another. Well, when you have something where it completely factors out, you don't end up with an asymptote where it makes the graph discontinuous. Instead, you end up with a hole that makes the graph look like it's continuous until you zoom all the way in on where that hole lives, and you'll notice that there's that small, teeny, tiny jump. So what this looks like algebraically when we have a hole is, if we look at this problem here, x squared minus 9 divided by x minus 3, we first need to factor the numerator. X squared minus 9, remember, is a difference of two squares problem, because that 9 is the same thing as 3 squared. So that means I can factor this into x plus 3 times x minus 3. So I would take the sum and the difference of the two perfect squares, the x and the 3. And then the denominator is x minus 3. Notice here the piece that factors out or divides out or cancels out are the x minus 3's, and it would leave me with x plus 3. So my simplified version of this equation is x plus 3. Finding the hole is at the location of what it was that of this factor that divided out. So x minus 3 is what divided out. So if I solve that for x and I add the 3 over, that means I'm going to have a hole at x equals a positive 3, and that is because x minus 3 divided out. And if you solve that for x, that's where we're getting our x equals 3. So we have a hole at x equals 3, and that's because the x minus 3 factor divided out. And if I solve that factor for x, I get a value of 3. This one's a little confusing just because there's a lot of 3's going on in this problem, so let's take a look at one more. We want to identify any holes in the function below, and then I'm also going to show you how to graph the holes. So I have x squared plus x minus 6. My first step is to factor my numerator. It factors into x plus 3 and x minus 2. My denominator then is x minus 2. That stays the same. Notice that the x minus 2's will divide out, and this simplifies down to x plus 3. So when I go to graph this, I'm going to be graphing x plus 3. That's a lot easier to wrap my head around graphing than it is to wrap my head around graphing the original form of it, which is x squared plus x minus 6 divided by x minus 2. The difference is that when I do graph this, to make sure that the x plus 3 graph is the same graph as the original x squared plus x minus 6 over x minus 2, I need to take into consideration the hole that's been created when I canceled out or crossed out those x minus 2's. So let's talk about the hole that has now been created. We have a hole at x equals positive 2, and again, that is because if I take x minus 2, set it equal to 0, and solve for x, I would add 2 to both sides, and I would get x equals 2. What that means for us is we are going to draw a grid to graph this function. 1, 2, 3, 4, 5. Oops, and 1, 2, 3, 4, 5. Okay, and then I'm going to create a table to represent this equation. You don't have to, but I'm going to. I'm going to pick some values that are positive and negative and 0. So let's do negative 2, negative 1, 0, 1, 2, and then let's do 4. I lied. Let's do 3. It doesn't matter. Okay, I plug in negative 2. Negative 2 plus 3 is 1. Negative 1 plus 3 is 2. Then I have 3. 1 plus 3 is 4. 2 plus 3 is 5, and 3 plus 3 is 6. Now, I have all these points, except remember that there's a hole at x equals 2. So this ordered pair of 2, 5 is not going to be a solid dot, but an open dot to represent the hole in the graph. Then I'll graph all the others. And this will then be the picture of my graph. All right, so that wraps up all of 5.4. You are now good to move on to the 5.4 homework assignment. I know that there were 2 parts of this 5.4 lesson, but the worksheet covers all of those pieces. And let myself or Mr. Brasser know if you have any questions. Thank you so much. Have a great day.